Welcome to Get Your FRQ On. This question is from 2023. It is question 5 and it is not calculator active. In the question stem, we're introduced to two functions, f and g, both of which are twice differentiable, and we have a table of values for f, g, and their derivatives for selected values of x. In part A of this question, we are introduced to a new function, h of x, which is defined as the composition f of g of x, and we are asked to find the derivative of h at x equals 7. Now, since f and g are both twice differentiable, so is our function h of x. This is important because we need to know that we can take the derivative of h in order to find h prime of 7. Now, this is also a composition, so we're going to use the chain rule here. H prime of x is f prime of g of x times g prime of x in general, and specifically h prime of 7 would be f prime of g of 7 times g prime of 7. We can get this information from the table. G of 7 is 0, g prime of 7 is 8, f prime of 0 is 3 halves, so we have 3 halves times 8, which is 12. So h prime of 7 equals 12. In part B, we are introduced to another function, k of x, which is known to be differentiable, and we are given that k prime of x is f of x squared times g of x. Using this information, we are to determine the concavity of our function k at x equals 4. Now, the concavity of the function k at x equals 4 is going to depend on the value of the second derivative of k at x equals 4, so we need to be able to find that derivative. Since f and g are, again, both twice differentiable, so is k of x. We need to know this so that we can be confident that k double prime of 4 is a thing that actually exists. So we can conclude that k is twice differentiable, so we know that k should have a second derivative at x equals 4. Now we just need to find it. All right, so k double prime of x would be the derivative of the first derivative of k. So we have d dx of f of x squared times g of x. Notice that this is going to require an application of the product rule and the chain rule. The derivative of f of x squared would be 2f of x f prime of x. Then we have to multiply that by g of x. That's the first half of our product rule. And then the second half of our product rule would be g prime of x times f of x squared. So now we have a formula for our second derivative of k. And then we just plug in 4 in for all the x's. 2 times f of 4 times f prime of 4 times g of 4 plus g prime of 4 times f of 4 squared. Get all those values from the table, and eventually, if you simplify it, you get all the way down to negative 40. Now, since k double prime of 4 is less than 0, k should be concave down at x equals 4. In part C of this question, we are introduced to another function, m of x, which is defined as 5x cubed plus the integral from 0 to x of f prime of t dt. We are asked to find the value of m of 2 and show our work. All right, so m of 2 would just be whatever you get when you plug in 2 for all the x's. 2 cubed is 8. 5 times 8 is 40. And then we have the integral from 0 to 2 of f prime of t dt. So we have 40 plus the integral from 0 to 2 of f prime of t dt. Now, what's interesting about this part of the question, and maybe a little tricky, is we don't actually know what f prime of t is. So how do we find its antiderivative? Well, we don't actually have to. This question is a straight-up application of the fundamental theorem of calculus. Whatever the integral from 0 to 2 of f prime of t dt is, it is the antiderivative value at 2 minus the antiderivative value at 0. Well, if f prime is the derivative of f, then f of t is an antiderivative of f prime of t, so we really only need 40 plus whatever f of 2 minus f of 0 is. Have no idea what this f prime of t function actually is, don't need to. So we have 40 plus f of 2 minus f of 0. F of 2 is 7. F of 0 is positive 10. And 40 plus negative 3 is 37. So m of 2 is 37. In part D, we are asked to determine if m of x is increasing, decreasing, or neither at x equals 2. In order to do this, we have to find a derivative of m of x evaluated at x equals 2 and determine the sign if it's positive or negative. That will determine if m is increasing, decreasing, or neither. So given the way that m of x is defined, m of x is 5x cubed plus this integral from 0 to x of f prime of t dt. Notice that this is the sum of two differentiable functions, so m of x is itself differentiable. Again, we need to establish that, otherwise how do we use the first derivative test on m of x if we don't know m is actually differentiable on the interval we're checking? So I have to establish that. Now if we differentiate m, we get m prime of x is 15x squared plus f prime of x. All right, so now all we have to do is plug in 2 into the values of x. So m prime of 2 is 15 times 2 squared plus f prime of 2. 2 squared is 4. 4 times 15 is 60. F prime of 2 is negative 8. 60 minus 8 is 52. And what's important to understand here is not necessarily that it's 52. What's important to understand here is that m prime of 2 is definitely positive. And since m prime of 2 is positive, m of x will be increasing at x equals 2.